Hello everyone, welcome to today's class. We'll be starting with a new topic, that's integration, one of the major topic of maths, okay, extremely major and lengthy also. Okay. So I've created a formula sheet which will help you to summarize all the formulas. So you can go through all the formulas, okay, and pretty much it covers all the ideas. Let's start from the basics, okay, and then we'll see formula as we progress through the topics. First of all, what's your integration? Basically, if you like, it is represented like this. Integration, this is the symbol of integration, with and dx represent with respect to which variable? Usually it will be x, okay. It's called integration of fx, also called antiderivative, because it's opposite of differentiation, antiderivative of fx, and also known as primitive. Of fx. So these three words can be introduced, like integration. Usually the symbol will be there, so that will help you. But if the question says find the antiderivative or find the primitive, that means you have to integrate that. Okay. Let's see. We'll start with the first basic formula. That will be mostly about this. Try to relate it with the differentiation. It will be easier. Okay. Now, differentiation of cos x is minus sin x. Okay, so the integration of sin x is cos x. Okay, plus c. Whenever we are doing integration, there is no limits present. Means from where to where we have to integrate 1 to 2. Okay, so the values of x are not given. This is called indefinite integral. Okay, so the point is, if we differentiate this right side, we'll get sin x. So we are not sure whether c was present there or not. Some constant could have been present or could not. So we just represent by c. Okay. Similarly, differentiation of sin x is cos x. So integration of cos x is sin x. Okay. Differentiation of tan x is sec square x. So integration of sec square x is tan x plus c. Differentiation of minus cot x, see cot x differentiation is minus cos x square. So minus cot x differentiation is plus cos x square. So cos x square x integration will become minus cot x plus c. Sec x differentiation is sec x tan x. So sec x tan x integration is sec x plus c. Similarly, cosec x differentiation is minus cos x cot x. So you take the negative to the other side. So integration of cos x cot will become minus cosec x plus c. Okay. Then one of the major formula that we'll be using in the first lecture is integration of x raised to power n. Okay, x raised to power n. So in differentiation, what we used to do, we used to decrease the power. We used to get the power down and decrease the power by 1. Same thing we'll do here also, just the opposite. Will increase the power. So if it is integration of x raised to power n, it will become x raised to power n plus 1, and your denominator will divide it by n plus 1 like this. Now in differentiation, this power used to come down in multiplication. Now what is happening? This power is increased by 1, and whatever power, it is coming down in the denominator. That's it. Okay. Then integration of 1 by x is log mod x by mod, because the quantity present inside the log cannot be negative. So just to make sure, that's mod x. Okay. Then e ki power x differentiation is e ki power x. So integration of e ki power x is also e ki power x. A raised to power x integration is, suppose instead of a there is some number 2, 3, 4, 5, something like that. Okay. So in that scenario, a raised to power x integration is a raised to power x upon log a. In differentiation, it was a raised to power x into log a. So you need these 10 results in starting. These 10. Basic of trigo, x raised to power n, 1 by x, e raised to power x, and a raised to power x. Okay. We'll start with these, and as we progress, we'll go through the remaining formulas also. All right. Let's start from the absolute basic. Okay. Integration x raised to power 4. Okay. So this is increase the power. So it becomes x raised to power 4 plus 1, and same whatever is the power 4 plus 1, you write down the same number in the denominator plus c. So basically x raised to power 5 by 5 plus c. Okay. So let's say integration of root x. Okay. So first of all, represent this by integration x raised to power 1 by 2 dx. Then do the same thing. Increase the power by 1 and same number in the denominator 1 by 2 plus 1. So x raised to power 3 by 2, and it will become 2 by 3 plus c. Okay. All right. 1 by root x. Again, remember I asked you to learn differentiation of root x. That was 1 by 2 root x. Okay. This one also will come a lot, so learn this. This is not a formula, but learn this. It will help you. Okay. So again, it becomes x raised to power minus 1 by 2 dx. Power 1 by 2 in the denominator. Okay. So x raised to power minus 1 by 2 plus 1 minus 1 by 2 plus 1. That becomes x raised to power 1 by 2, 2 plus c, or we can say 2 root x plus c. So differentiation of root x is 1 by 2 root x. Integration of 1 by root x is 2 root x. Okay. So learn this. Let's take one more example, basic 1 by x cube. So 1 by x cube is integration x raised to power minus 3 dx. That's x raised to power minus 3 plus 1 minus 3 plus 1 dx is equal to, this becomes minus 1 by 2 x raised to power minus 2, or it will become minus, sorry, once we have done the integration, remove the sign of integration, plus c plus c. So this becomes actually minus 1 by 2x square plus c. Okay. Then comes another property, integration of e raised to power 3 log x dx. Now if you see, e is there, log is there. That was a property. Then if e raised to power log is there, you can cancel it. But the problem is there is e raised to power x, sorry, e raised to power log should be there. So what we can do is we can take this 3 in the power of x. Let's rewrite this as e raised to power log x cube dx. And then what happens is e and log cancel each other. So what you are left with is only integration x cube. And now it's a basic question, x raised to power 4 plus x raised, increase the power. Okay. So x raised to power 4 by 4 plus c. Okay. All right. One second. Yes. This is the property that we used. E raised to power log x is just x. Okay. And there is another modification of this property, or I'll add it here. Another variation is like, suppose a is there, so a raised to power log, and your base should also be a, x. Then also what happens is this becomes just x. Means a, if instead of e there is a number a, so the base of the log should also be a, then they can cancel each other. Okay, all right. So most of the properties I have mentioned in this sheet will be here, so as they come we'll discuss that. Okay, so this is done. Now using the same concept, let's look at one variation of it. The concept can be extended to a question that looks weird. E raised to power 5 log x minus e raised to power 4 log x upon e raised to power 3 log x minus e raised to power 2 log x. Okay, one notation that will be used in the exam. See, if log x, this is something that I have discussed in differentiation also, but log x means log base ex, also known as ln x. Okay, so if you see this representation, still mean the same thing. Okay. All right. Now same concept we'll use. We'll take these number to the power because then we can cancel the log. So this becomes integration dx. Okay. So this becomes integration e raised to power log x raised to power 5 minus e raised to power log x raised to power 4 upon e raised to power log x cube minus e raised to power log x square dx. Okay. So e and log cancels, log cancel, log cancel, log cancel, log cancel. What do we get? We get only x raised to power 5 minus x raised to power 4 upon x raised to power 3 minus x raised to power 2 dx. Now right now we don't know anything about the product rule or UV rule, but it's called by parts actually. But there is no such thing like u by v in integration, that I'm telling you. Means you will never be able to integrate a function if it is in numerator and denominator as well. So most of the time denominator is the problem of integration. Okay, so somehow we have to adjust that. Okay, so let's take it out. What we can do, we can take x square common, x minus 1. We can take x raised to power 4 common, x minus 1. So sometimes you have to do the adjustment accordingly. X raised to power 2 cancels this. So this becomes a simple x square dx integration. That's x cubed by 3 plus c. Okay. Increase the power. Okay. All right. Next question. Before starting the next question, what properties we'll be using is again from the trigo. Okay, this property. Although this will be certainly used directly for sine square cos square integration, but 1 minus cos of double angle, 1 plus cos of double angle. Okay. This is something that I emphasized in trigono also. We discussed this in inverse also. We discussed this in differentiation also. So all these will be again used. So 1 minus cos to theta, 1 plus cos to theta. So basically we need the formula of cos. Okay, I'll write it here. This is how you are supposed to learn this. 1 plus cos to theta is 2 cos square theta, 2 cos square angle half. 1 minus cos to theta is 2 sine square angle half. And directly you should know that cos 2x or cos 2 theta is cos square theta minus sine square theta. It's also 2 cos square theta minus 1. It's also 1 minus 2 sine square theta. This is something we discussed in the trigo. Now look at the questions. Just because of these properties again, okay, the questions will be very important and you might not be able to get the idea. look at the question. 2 upon 1 plus cos 2x dx. The moment first thing I told you that the denominator is a problem of integration majoritively. So 1 plus cos, somehow we have to simplify this. So what is the moment I see 1 plus cos, I know this property, 2 cos square angle half. So 2 upon 2 cos square x, 2 cancel. What is 1 by cos square? That's sec square dx. And sec square we should know. What is sec square integration? Tan x. If you forget, try to think like this. What is the differentiation that will give us sec square? So tan x differentiation will give us sec square. Okay. Next. Same idea, same representation, just replacing plus with minus. So same thing, just what is going to happen? 1 minus cos property will be used. So this is 2 upon 2 sine square angle half. So angle is 2x, so half of that is x. Again 2 cancel, 1 by sine square is cosec square x. What is the integration of cosec x? So try to think what differentiation will give me cosec square, cot x basically. But cot x will give you minus cosec square. So minus cot x will give you plus cosec square. Okay, that's your answer. All right, done. So sometimes the questions are very straightforward. It's just that the representation will look like slightly typical. Cos 2x plus 2 sine square x upon cos square x dx. A lot of trigo, but you see, what do you see? You see double angle in this, and you see 2 sine square. So cos 2x of course can be opened in many ways, but if I use the opening of cos in 1 minus 2 sine square, this will help me. Okay, so I'm going to use 1 minus 2 sine square angle of half. So 2x half is x, so plus 2 sine square x upon cos square x. Okay, same thing, minus 2 sine square cancels. So integration 1 by cos square. What is 1 by cos square? Sec square. We know integration of sec square is tan x plus c. Okay. Same idea, just that 2 cos square x minus cos 2x. Remember that just learning the formulas of integration will not get you anywhere. You need to have the ideas, you need to have approaches, and that can be developed with a lot of examples. Okay, so I'll be discussing a lot of questions in this, lot of variations. Each and every question will be slightly new than the previous one. Okay, this time we have done the question that was just discussed above, so same idea. It's just that you have to decide how will you open cos 2x, because first thing is that this is double angle. Second thing is there is 2 cos square present. So I'll open cos using 2 cos square minus 1, this one. This will help me. So let's open it. So integration 2 cos square x and minus 2 cos square x minus 1 upon sine square x. I have replaced cos 2x by 2 cos square minus 1. So this becomes integration 2 cos square x minus 2 cos square. I don't have to show you the steps. 2 cos square cancel, negative becomes positive. So plus 1 or just 1 by sine square. What is 1 by sine square? That's cosec square. We know that integration, cosec square integration is minus cot x plus c. That's the answer. All right. Let's go to the property that we discussed about E. Let's see a few more questions of that. Okay. Integration e raised to power x log base e a. So the moment you see lot of symbols, you might get slightly confused. Okay. dx. Now the first thing we should know is that e and log will cancel, so let's take it in the power, and base e is given. I told you whether base is given or not, this is the same thing. So this is nothing but integration e raised to power log base e a raised to power x, and the point is e and log will cancel. What do we get? Integration a raised to power x. Now that's a standard result. What is integration of a raised to power x? It's a raised to power x upon log a. Like, what is the differentiation of a raised to power x? A raised to power into log a. So integration is just opposite. So instead of multiplication of log a, we have division of log a. All right, next one. Integration e raised to power a log base e x dx. So same thing, just notations, symbols are varying. This time a is outside, x is inside, so, but we'll do the same thing. Integration e raised to power log base e x raised to power a. E and log will cancel, dx. So this becomes integration of x raised to power a. Okay, this is log base e. Log base e actually cancels. Okay, so this is becoming x raised to power a integration. Now try to relate it with x raised to power n. Okay, the variable is in the base and the power is a number a, we don't know, so we just increase the power, a plus 1 upon a plus 1 plus c. Okay, so instead of n in the formula you have a. Next question, e raised to power x a raised to power x dx. So now multiple terms in product. Again, right now there is no such rule for product also. Okay, it is there but it will come later. Right now we don't have any rule. So how do we approach this? I see power being same in both the expressions. So I'll write this as EA complete raised to power x. And just try to think of this as some variable p. Okay, this is like some variable p. Okay, or let's call it something as capital A. Okay. Okay. So what you will see is a raised to power x. What is the integration of a raised to power x? Same thing, a raised to power x, but upon log a. What is a? EA. Sorry, e small a. Plus c. Now they can give you this as an answer, but I think there is a possibility to solve this slightly further. What is that? You can split this log in two parts. Okay. EA raised to power x. Product can be splitted about addition, log e plus log a. Now what is log e? Log e is, remember that log e means log e base e, that's 1. Okay, what should be the power of e? So you get e 1. This is the meaning. So this becomes e a raised to power x, or if you want to split it, that's not a big problem. 1 plus log a. That's the whole point of this. Okay. All right. Let's look at one more property. 2 raised to power log base e x. Now this time the variable is in the log of power of 2 basically. It's inside the power of 2 and inside the log. Now there is one more property. I think it is not mentioned in the sheet. I'll add it. Okay. Another form property is let's suppose you have x raised to power log whatever the base is, okay, y. This is same as y raised to power log a x. Means you can interchange your base, not exactly base, your x and y, whatever is present in log and the power, the base whose power is log raised. So you can interchange these two. So try to learn like this, that these two are interchangeable. Okay. and this is what we are going to use. So that means, again, just try to learn it like this. We can interchange these two. Now why that helps? Okay, this becomes, after the interchanging, it becomes x raised to power log base e2. So right now, if you think this is some number, log 2 is some value. Okay, ln2 na, ln2 is 0.301, I think. Okay, so point is, this is some number. So as long as you have a constant in the power, so we have to do the integration like x raised to power log base e2 plus 1 upon log base e2 plus 1. Okay, and now again same thing. What we can do is further simplify this. This could be one of the answer, but we can still further simplify. What do? We replace this one by log e. Okay, same property here that I mentioned. This is already mentioned in the sheet, so no need to note this separately. So further, this becomes x raised to power log base e2 plus log base ee. Okay, upon log base e2 plus log base ee. So in addition of log, it becomes multiplication. So log base e 2e upon same thing log base e 2e plus c plus c. That's your answer. Okay. So they can confuse you regarding the manipulation of the result. The integration is simple, but sometimes, like if the options are given, suppose this question is an MCQ form, so the options could be like this and you will be getting like this. So you might think that what is the problem, why the answer is not correct. Your integration is correct, but your answer could be slightly with the variations. Okay. All right. Let's look at few more questions. So I'll start again with the slight basic part. 4x raised to power 5 dx. So not a problem. Same thing that happens in integration, same thing happens in the differentiation. You can split the integration and differentiation both about your plus and minus, and if there is a constant being multiplied, you leave it outside and integrate the remaining part. Means we'll integrate only x raised to power 5. So what is the integration of x raised to power 5? X raised to power 6 by 6 plus c. Okay, so basically you can slightly simplify this as 2 by 3. Okay, all right. So let's say 2 sine x. So again, you leave the 2, just integrate sine x. Integration of sine is minus cos x. So 2 minus 2 cos x plus c. That's your answer. Okay, next question. 3 raised to power x plus 2 dx. Now I'll teach you this, I think, when ax plus b format comes. So for the time being, you can leave this. Okay, the format is ax plus b, so we'll deal that when it comes. Okay, so leave it for now. This can be done without it also. Okay, but I'm saying that it is easier with ax plus b format. I'll give you the answer with normal approach. So I would, right now we don't know this ax plus b format, so what we can do is we can split this in two parts. Okay, we can write this as 3 raised to power x into 3 raised to power 2. Again, 3 raised to power 2 is constant, so leave it 9 or 3 raised to power 2 as you want, and integration of 3 raised to power x is 3 raised to power x upon log 3 plus c, and you can again combine them. Okay, combine these three, so 3 raised to power x plus 2 upon log 3 plus c. So for the timing, this is the answer, but this is not the correct, or this is the correct approach. It's not the shortest approach. The shortest approach is ax plus b format. Okay, so this is the easy approach. Okay, all right. Then integration of 1 by 2 sec square x dx. So integration of 1 by 2 sec square. So 1 by 2, leave it. Integration of sec square is tan x plus c. That's the answer. Okay. All right. x cube plus 5x square minus 4 plus 7 by x plus 2 by root x dx. Okay. This is your question. Now integration can be splitted about plus and minus also, so that means you have to integrate each and every term, this one, this one, this one, this one, this one separately. Okay. So x cube directly x raised to power, increase the power, 4 5 by 3 x raised to power 3 by 3, okay, minus 4. So we have not talked about what is the integration of a constant. So integration of only a constant k is kx plus c. So you introduce x with it, because try to think of what will be the differentiation of this. So constant differentiation 0, integration differentiation of kx will be k. Okay. So minus 4 integration minus 4x, 7 by x, 7 by x. Remember, this cannot be done with x raised to power minus 1 integration, like increasing the power, because the problem is if you increase the power, the denominator becomes 0. And separately, you should know 1 by x integration is log x. So 7 log x. Okay. Plus, I told you to learn the integration of 1 by root x. 2 into 1 by root x integration is 2 root x plus c. So 2 into 2 becomes 4. So directly write down 4. Okay. So that's the idea. Okay. So if you have individual terms, you can integrate them. What if you don't? 5x square plus 4x plus 1. The problem is this is divided by x square. The moment it is being divided by x square, now you don't have a separate terms. But the good thing is, what is the idea here? Idea is single denominator. So I'll be using this term, single denominator. The moment I say, you should think that what if we split this? Single denominator. So what we'll do, I'll split this x cube by x square. Right now I'm showing each and every step, and after that I'll not. 4x by x square plus 1 by x square. This is the idea. You split the term regarding the about the denominator, each denominator. Okay. So now this becomes integration x plus 5 plus 4 by x plus 1 by x square. And now this is easy. This is like the same question, integrated. Integration of x square by 2, constant, you add x with it, okay, multiply x with it. 4 by x is 4 log mod x plus 1 by x square integration is x raised to power minus 2. So minus 2 integration is x raised to power minus 2 plus 1 minus 1 upon minus 1. So this becomes actually minus 1 by x plus c. You can do the integration of one particular term separately and get the answer in one go. Okay. Next is integration 1 minus x root x dx. Again, if you see, there is being multiplication. I told you right now we don't have anything with the multiplication. There is no rule. So what do? We literally multiply this. So integration of root x minus x root x dx. Now what is root x actually? X raised to power 1 by 2. What is x root x then? 1 by 2, and this is power 1. So x raised to power 3 by 2. Now you integrate this. So x raised to power 1 by 2 plus 1 is 3 by 2. So power 3 by 2, this will be 2 by 3 minus here 3 by 2 plus 1 is 5 by 2. So here it will be 2 by 5 plus c. Okay. Okay, next question. Integration of root x plus 1 by root x whole square dx. Now integration of this, see again whole square is there. As long as there is a whole square, we cannot directly integrate it. Okay, so what we can do is right now just open it. So root x whole square is x plus 1 by x plus 2 root x 1 by root x. So good thing that we opened it. So what is integration of x? X square by 2. What is integration of 1 by x? Log mod x. Plus 2 integration is, because this cancels, so integration of only 2 is 2x plus c. Okay. Alright. We can slightly complicate this. 1 plus x whole square integration divided by root x. So whole square is there, denominator is there, but I'll tell you again the same thing. You have a single denominator. If it's a single denominator, we'll split this. But the point is whole square is there right now. So we can not directly do this. So this is integration 1 plus x square plus 2x upon root x. I'll write directly. Root x is x raised to power 1 by 2. So x raised to power 1 by 2, x raised to power 1 by 2, x raised to power 1 by 2 dx. So that becomes integration x raised to power minus half. This becomes x raised to power. Now you have to use the property of exponents, power subtract in division. No? So 2 minus 1 by 2, 3 by 2. 1 minus 1 by 2, 1 by 2. And after this, I think it is pretty standard. X raised to power minus 1 by 2 integration is, this was 1 by root x. Na? So what is 1 by root x integration? 2 root x we know. This will become x raised to power 3 by 2 plus 1, 5 by 2 upon 2. 2, this is square root of x. So 2 into power increase 3 by 2 into 2 by 3. So this becomes 2 root x, 2 by 5 x raised to power 5 by 2 plus 4 by 3 x raised to power 3 by 2 plus c. Alright, look at the next question. X cube minus x square plus x minus 1 upon x minus 1. This time you don't have a single denominator. So suppose you do this, x cube by x minus 1 minus x square x minus 1 plus x upon x minus 1 minus 1 upon x minus 1. It's not helping our case. Okay. It's a single denominator, it's x minus 1, but this is not helping our case. So what do? The problem with the integration, I told you, is most of the time denominator. So somehow I have to get this x minus 1 separated or get eliminated in some way. So if you look at these two terms and look at this, x minus 1 is already there. If I split it about this positive, this could have helped my cause. And x cube and x square, I can take x square common and it will also generate x minus 1. So I'll generate it. X square I have taken common, x minus 1 plus x minus 1. And now I split this in two parts, x minus 1, x minus 1, like this. This helps it because this cancels, this cancels. See, the idea is to eliminate the denominator here. So x cube plus, x square plus 1 dx. This is a simple question, x raised to power 3 by 3 plus x plus c. Okay. Sorry, integration. This is done. All right. Let's look at the next question. Integration x raised to power 4 plus x square plus 1 upon x square minus x plus 1. Okay. This question can be done in two ways. I'll give you a short approach. For that you have to learn one new formula, of course. Another one is standard approach, but again that standard also requires variations in it. Okay. We'll see. Let's go by standard approach and then I'll give you the shortcut. You'll appreciate that. Okay, so what I'm going to do, and you'll think why I'm going to do that particular thing. I'm going to generate 2x square. Why? Because if 2 was there, it could have been a square b square 2ab. Okay. But I cannot generate that directly. So what I'm going to do, I'm writing 2x square forcibly, of course, but I'm subtracting x square, so effectively it is the same expression, divided by x square minus x plus 1. Okay, so this particular term, if you look at this, so this is the adjustment I made. Okay, this particular term is what? X square plus 1 whole square minus x square upon x square minus x plus 1. Okay, a big denominator is there. Just use the property of a square minus b square, so it will give you x square plus 1 plus x square plus 1 minus x upon x square minus x plus 1 dx. Okay. Now this thing is good because you look at this, these two are same, so this cancels and effectively you don't have any denominator anymore, only integration of this. So let's directly integrate. X square integration is x cubed by 3 plus x square by 2 plus x square by 2 plus c. That's the answer. Now the point is, it's a unique kind of question. Okay, this will not happen in a lot of questions. This is a unique approach. So the short way to do this is that you should know this result, that x square plus x plus 1 into x square minus x plus 1 is equal to x raised to power 4, x raised to power 2 plus x raised to power 1. So you can replace this numerator directly with this, and after that it becomes very simple. Okay. Learn this, but the problem is this is specific to this question. Okay, it's not going to be used anywhere else. All right. Then let's come back to the properties of trigo again. This time square root of 1 plus cos 2x. Again same thing, 1 plus cos. You see where I'm going with this? This becomes integration. Okay, the question is integration and dx. So 1 plus cos is inside root 2 cos square x. Now this is good because it becomes integration root 2 cos x, and we know we can integrate cos x. Okay, integration of cos x is minus root 2 sin x plus c. Okay, sorry, cos differentiation is minus sign, so plus. I learned it like this: differentiation of sine is cos, integration of sine is minus cos, differentiation of cos is minus sine, so integration is plus sine. So every time you go from differentiation to integration, you change this positive negative. Okay. Next, same thing, just 1 minus cos 2x dx. Okay. So that is root 2 sine square half of angle, so that becomes root 2. Okay, this is integration root 2 sine x dx. So integration becomes root 2 minus cos x plus c. What if the question was integration 1 plus sine 2x? Okay. This is interesting. No, this one is okay. The interesting part is 1 minus sine 2x. Let's do this first. There's no such thing as 1 plus sine 2x, a direct formula. But again, I'll ask you to learn the idea. Don't learn the property as such, learn the idea that if you see 1 plus sine 2x, 1 plus cos you will know because that's a standard property, but learn the idea of 1 plus sine 2x. What do? you write down this sine 2x as 2 sine x cos x, and this one as sine square x plus cos square x. The good thing is it becomes an identity, a square plus b square plus 2ab. So this becomes square root of sine x plus cos x whole square dx. Okay. So this square and square root will cancel, so integration of only sine x plus cos x. What is integration of sine x? What is integration of cos x? Sine x integration is minus cos x. Cos x integration is sine x plus c. That's the answer. So no problem with this, but what if the question is square root of 1 minus sine 2x? Integration dx. Idea is still the same. We'll do the same steps. Integration square root. We'll write this as minus 2 sine x cos x. I've used the property of sine to theta. Okay. In case somebody is not able to record, sine 2x is 2 sine x cos x. Okay. Again, this is pretty standard. So for integration, I'll suggest that you go through all the formulas of trigo. Because the questions of trigo are not lengthy from integration point of view, they are just tricky with the properties itself. That's why I have to discuss so many questions, so many variations. So now integration, it becomes square root of sine x minus cos x whole square. So square root and this cancels, so this becomes integration of sine x minus cos x dx. Okay. So integration of sine x is again minus cos x, integration of cos x is sine x plus c. That's the answer, but the problem is this is only one of the possible answer. Okay. As such, if you look at the question on anywhere, in any books also, this is the given answer, but the problem, there is some problem with this answer. The problem is, I can assume it to be a square plus b square, right? Plus 2ab. I can assume it like reverse also, na? B square plus a square. I can assume cos is my a. That means I don't have a implication that I have to write this as only sine x minus cos x whole square. I can rewrite this as or cos x minus sine x whole square also. Both are correct. If you open it, both will give you the same result. The point is which one is correct and which one is not. That's the whole sense. Now again, it depends on the question. The question should give you the further information. Okay. So I'm not saying this answer is incorrect. This is only one of the possible answer. So there are two answers for this question. Now point is which one is correct, which and when it's correct. Okay. The idea is that the result of square root should always be greater than 0, means positive. Okay, square root result should be positive. Now how do you know sin x minus cos x will be positive or cos x minus sin x will be positive? It depends on the interval. Okay, so again going back to the basics, I think I've discussed this already once. Let's still discuss. You draw the graph of sin x, you draw the graph of cos x. Okay, we need only like the first cycle of this. I'll still draw the full. Like this. Okay, red one is cos, this one is sine. Okay, the values are this particular value, I will say, where sine and cos are equal. Where when is sine and cos equal? At 45 degree or pi by 4. Okay, this is pi by 2. Okay, so if the interval is, this is correct. So you look at 0 to pi by 4. In 0 to pi by 4, cos is above the sine, means value of cos is more than sine. That means this expression is correct for x belongs to 0 to pi by 4. And this expression is correct for x belongs to pi by 4 to pi by 2. So in the interval of pi by 4 to pi by 2, we look at this interval, your sine, the black curve is above the red one. So that means sine is more than cos. So sine x minus cos x will be positive. So this is the correct answer for interval x belonging to pi by 4 to pi by 2. Whereas this is the correct if the interval is 0 to pi by 4. Okay. This is, I think, something that was discussed in inverse trig also, I think. Okay. But anyway, the idea is that the answer of square root should always be greater than 0. So for that, there is two possible answers. Okay. So this becomes cos x minus sin x. So the question should mention this, but remember, you should know now that there are two possibilities. So, or the cos x answer, integration of cos is sin x. Sin x integration is minus cos x plus c. So you look at the answers, there are two possibles, okay, for this question. All right. Let's look at few more questions. Integration of tan square x dx. Okay. Another basic use of some properties. Again, recalling the properties of grade 10th, 1 plus tan square theta is sec square theta, 1 plus cot square theta is equal to cosec square theta. Properties of grade 10th. You know, there is as such no standard result of tan square, but sec square could have been integrated if only this was sec square. So generate sec square. So sec square can be generated from like tan square. I can rewrite this as tan square is sec square minus 1. So use this property. Try to generate sec square out of it. So if we generate sec square, this becomes sec square x minus 1. And now we can integrate. Sec square integration is tan x. 1 integration is x plus c. So using this now, then integration of cot square x, same idea, absolutely same idea. Integration of cosec square x minus 1. So it becomes integration becomes cosec square integration is minus cot x minus x plus c. Okay. Next, integration of 1 upon sine square x cos square x dx. Now look at this question. There are two denominators. There is no numerator. How will you even cancel it? You cannot. So if only numerator was there, but we know we can replace this again using the property of trigo. I'll add that also. What is that? That sine square theta plus cos square theta is 1. Okay. So write down integration sine square x plus cos square x and just split the denominator. How will you split it? Sine square x cos square x in the first term also as well as the second term. Sine square x cos square x. What is the benefit? Something cancelling. Sine square cancel, cos square cancel. What is 1 by cos square? That's sec square. What is 1 by sine square? That is cosec square x dx. This is standard result. Tan x minus integration cosec square minus cot x plus c. Okay. All right. Let's look at one more question. Same, pretty much close enough idea. Cos 2x this time. So at least something is in the numerator, and denominator is still the same, sine square x, cos square x. Now what is cos 2x? Remember, one property of cos 2x is cos square x minus sine square x. Okay. And you have the same denominator, sine square x, cos square x, split it in two parts. Sine square x, cos square x. What is the benefit? The benefit is that we can still cancel this. Cos square, sine square. Integration dx. So 1 by sine square is cos x square. 1 by cos square is sec square dx. Again, same thing. This becomes minus cot x integration. This becomes sec square integration is tan x plus c. Okay. All right. Next question. This is integration sorry 2 plus 3 cos x upon sine square x. Again, same idea, single denominator. Let's split it. Let's see what happens. So 2 by sine square means 2 cos x square x. It's a good thing, 2 cos x square x. But 3 upon cos x by sine square x. No? So I'm writing this as sin x. You'll see why. Combine this cos by sine. What is cos by sine? So this integration is already done. So okay, so 2 cos x. Let it write to me. Let's write it. We'll solve it in one go. This becomes cos by sine is cot x, 3 cot x, and 1 by sine is cosec x. So somehow I generated the standard formats. What is the integration of cos x square? Minus 2 cot x. What is the integration of 3 cosec x cot x? Is minus, leave the 3, minus cosec x and plus c. Okay. Done. All right. Next question. Integration of 2 tan x minus 3 cot x whole square. Now tan x minus cot x, as such, we cannot do too much about it. And there is a whole square. So whole square opening bit will be helpful. Why? 2ab term will multiply tan and cot cancel each other. So let's write down. So this becomes integration of 4 tan square x plus 9 cot square x minus 3 to the 6 to the 12 tan x cot x. And tan and cot, they cancel each other. Cot is 1 by tan, so they cancel. So tan square, we can integrate it by the idea that we learned, sec square x minus 1. Similarly, this can be integrated by 9 cosec square x minus 1 minus 12 dx. Okay, so let's rewrite this. Integration 4 sec square x plus 9 cosec square x minus 4 minus 9 becomes minus 13 minus 25 it becomes dx. Okay. So the integration becomes 4 sec square integration is tan x, 9 cosec square integration becomes minus cot x minus 9 cot x, 25 integration is 25x plus c. Okay, you always have to write c with this, a constant. All right, last question for today's session. Cos 2x minus cos 2a upon, or alpha, whatever you want to call it, upon cos x minus cos a. Now you see, the only numerator has double angle in it. So again, somehow we have to use the property of double angle. Okay, and point is cos also opens in three ways. So which one I'll use? I'll use in which cos is there, because the denominator also has cos in it. So what is cos 2x? 2 cos square x minus 1. Go through the properties. Okay, I've mentioned it in the integration starting also. Okay, minus this becomes 2 cos square a minus 1 upon cos x minus cos a integration dx. Okay, so now this becomes 1 and 1 will cancel when you open it. This becomes positive 1, so it will cancel this. So this becomes 2 common, it becomes cos square x minus cos square a upon cos x minus cos a. Integration. Sorry. A square minus b square we can apply. Now this is very helpful. Why? Cos x minus cos a, same as the denominator, cos x plus cos a. Now this is very helpful. Denominator cancels, the main problem of integration done. So all you have to do is integrate 2 cos x plus 2 cos a dx. So what is the answer? Usually the students will write integration of cos is sin x. So 2 sin x plus 2 sin a plus c, and this is where they are wrong. Why? We are integrating with respect to x, so cos x integration is sin x, fine, but cos a is some number that we don't know, it's constant. What is the integration of constant? 2 sin x plus constant integration is just apply x with it, so 2 x cos a plus c. This will be the answer, na? So remember that if you write down 2 sin a, that will be the wrong answer. Okay, usually this mistake happens a lot. Okay, we get casual and this mistakes happens all the time. All right, I think that's it. That's a lot of information for one class. Go through all the questions. All questions are unique. A lot of variations is there in integration, so a lot of effort is required on your part. Okay, we'll continue with these kinds of questions also in the next class. Okay, all right, that's it for this session. Just learn those 10 formulas. Okay, good day everyone.